at something kind of similar to factorizing. You can do it on quadratics, and it's called completing the square. What happened to you? What's wrong? Really? It's too high. I don't know what I can do. If you need to move back, there's seats, you can move back. Sure? Alright. Okay. Completing the square. Okay. Come on, hurry up, guys. So, if I go from this to this, what's this called? What's this verb? Expand. And then if I go from here back to this one here is called factorize. Now there's another special form we could have. Have a look at this, for example. Let's expand this. Something like this. So let's expand. So this is x plus 1 times x plus 1 plus 1. And we all know how to multiply this out. So this is x squared plus 2x plus 1 plus 1. Actually, you know what? I'll make it, no, I'll leave it like that. This is x squared plus 2x plus 2. So again, the verb for going this way is expanding. But what we'll be interested in today is going from here back to this form. So this is what we want to learn how to do today. So this process is called completing the square, which is the name of the lesson. So I guess it's kind of like a verb, completing the square. So we'll learn how to go back to the form there. Have some people seen this form before? Yeah. And why is this form useful? Does anyone know? Yep. This form can help you find the max and the min. This is why it's useful. Also, another reason it's useful is here that the x is twice, but here the x is only once. So this is another reason it's useful. Okay, so let's see the process, how to complete the square. So there are two types. You can have ones like this, or you can have it like this. So we'll just look at these examples first. Does anybody remember the name for this quadratic? This is a quadratic, but there's a name you put here that means the a is 1. Anyone remember? No? Yes. Monic. Yeah. Everybody forgot this, so please write this down again. Monic quadratic. Okay. You got that? Yeah. Alright, so let's have a look at the process. So I think the best way to do it is maybe with some numbers as the first example. So the process goes like this. First we put down our brackets with a square and then a plus and then an x. And a plus if you like. So you're looking for, hey, I'm hearing Chinese. Question? No question, great. Okay. So you're looking for two numbers here. So the number in red is always the easy one to find. This number that goes in here is always half of this number. So since this is positive 4, this one will be positive 2. Positive 4 will be also positive 2. And of course if it was minus 4, then it would be minus 2. So exactly half. Okay. Getting the number at the back here, it's a little bit trickier, but not much. What you do is 9
minus
yeah,
square root.
very good. It's 9 minus the square of this. So it'd be 9 minus 4. Now, before anyone asks me, it's always minus here. Doesn't matter. Always minus. So this is always minus. And the 9 here is because of the 9 here. Plus 9 makes plus 9. If it was minus 9, it'd be minus 9. Minus, always minus, and 4. Will this number always be positive? Yes, because it is the square of this number. So it must be positive. So this here will be 5. Now, I'll just show you that this does work. So this is equal to x plus 2 times x plus 2 plus 5, which is x squared plus 4x plus 4 plus 5, which is x squared plus 4x plus 9. So it's the same. You don't need to check the answer like this in the exam. I'm just showing you that if you multiply it out, you do get the same answer. Okay. Right, did you write that down? Yeah, it's not much there. Let's try another one. And you can do these really, really quick. X squared plus 6x plus 18 equals, okay. What's first? X plus 3. And then it'll be 18 minus
9.
18 minus 9, which is 9. This is the answer here. So this one was 18 minus 3 squared, and this one was half of 6. That's okay. Alright, so let's, now that we have the basic idea, let's make one a little bit more difficult. So let's say x squared plus, let's put a fraction in it, plus 9x plus 105 over 4. Why not? Why not? Okay. I'll give you a minute. Do this for me. Might need to use your calculator, but so what? It's the same way. And you students, have you got calculators? Not yet, that's okay. Who has that Casio 991 calculator? Does anybody? Nobody? Nobody has it. What calculators does anybody have a calculator? Oh rats, I lost my calculator again. No. This is the one we recommend for the course, which nobody has bought yet. Did anybody buy this one yet? Oh good. This one? Look to your left. That one. This is the best one. You have the same one, yeah? But there's no real difference except for the solar panel. Yeah, this one is the best one.
Is this okay?
It is okay, but this is best, this one. Yeah, if you want to write the name down, it's Casio 991. It's the best one to use. Well, it's the best one I know you're allowed to use. Okay, so I'll give you a minute to do this one. You might need to use your calculator, so I'll give you a minute. Yeah, you have it, yeah? Yeah?
Do we need to write the steps up?
No, you can go direct to the answer. It's okay for this. It's like the factorizing, you can just do it directly. Okay, so what do we have in the middle here? 9 over 2. Now the piece at the end will be 105 over 4 minus 81 over 4, which is what, 24 over 4? Which is 4, yeah. 24 over 4, which is 6, yeah. Plus 6. Plus 6. So this is the answer here. Okay. Can I go down? Yeah. Alright, so what do we do when we have non-monic? So let's see if anybody has any ideas. Any ideas? What could we do here? Yeah, but there's no equal sign. You know, it's not like if this was equal to 0, you could divide by 7. But there's no equal sign here.
Take 7.
Take 7 out. Yeah. I know it's nearly the same thing. Yeah. Okay, so if we take 7 out, this will be x squared minus 10x plus 183 over 7. Okay. So now the piece that's on the inside is just a normal problem. So this will be 7. And what will I have here? What will be here? X plus or minus? Minus 5. And now this last piece here will be 183 over 7 minus what? 25, which is 175. No. Yes. 175 over 7, which is 8 over 7? Yeah. All right. 8 over 7? Yeah. Not quite finished. You look confused like I did it wrong. Is it not 8 over 7?
Multiply by 7, so...
Yeah, well, there's still one step left. Yeah. 183 over 7 minus 25. Yeah, no. That's right. And as you said, the last step is to multiply by 7. So you have 7 x minus 5 squared plus 8. So this is the completed square form. Okay, can you write this one down as well now? You can get this in the exam. You can get both possibilities in the exam. You got it? Yes? Okay. Now, for those people who have seen this before, you already know some people, well, most people will know the shape of this graph. What type of shape will it make? What shape will this graph be? Will it be a straight line? No. It'll be this U shape. There's two possibilities, isn't there? It could be this type of shape or this shape. Yeah. So it'll be the first one. Yeah. So the idea is we have some minimum value here, which we want to find. So I want to know now, what is the minimum the y can be? Okay. Question? Hey, what's wrong? Thinking about what? Maths, I hope, yeah? Maths. Okay, so yes, some people have it, but if we look at the reason why. So here, you want to make this a minimum, and here you want to make this a minimum. Now on this piece, you don't have any choice. It's always going to be 8. But what's the smallest this could be?
0.
It could be 0. Why can't it be negative? Because the square means it's positive. So if this could be 0, then you can see the smallest value of y has to be the 8. So in other words, this number here is always the minimum value. This 8 at the end. The number at the end is always the minimum. Because we can make this piece 0. Now the next question is, what do I choose for x to make this 0? Well, it has to be, I'll use a different colour here. It has to be 5. That's the only way to make this 0. So the minimum happens when x is 5. See, the idea is if you have y equals a x minus b squared plus c, where will the minimum happen? When x is b, yeah, and then the y will be c. So this is like a result. Now, sometimes it's a minimum, but sometimes it's a maximum. How can we tell which it is from A, B, and C? The A can tell us. If the A is positive, then the shape of the graph is like this. So this is for a positive A. A is positive. But if the A value is negative, then it'll be this shape. Now, what's the reason for that? Well, if you think about it, if there's a minus here, then this can be negative. The biggest it could be is 0. Could this be positive? Well, it couldn't if the minus is here, because a minus multiplied plus is still a minus. I'll give you a number example. Like if you had y equals minus 2, x minus 1 squared plus 3. This is positive, this is negative, and together? Negative. What's the biggest this could be? It's 0. Can it be positive? No, because of the negative here. So the biggest it could be is 0. Yeah. So anyways, if the A is positive, you'll have a min. And if the A is negative, you'll have a max. But it's always the same. Min or max. It's always this number for the x and this number for the y. Please be careful. This is a minus here and this is a plus. If this was a plus, then here you just put a minus. It's the opposite sign. Because remember, you want to make this piece equal to 0. Yes? Okay. Can I scroll down? You have this? Yeah. Okay. Right, let's try this one. Let me give you one to try, actually. So, what I want you to tell me is... oh yeah, sorry. Actually, I should give you a bit of vocabulary here. 183. There's a word that means minimum or maximum. Does anyone know it? Yeah. Yeah, what is it? In English, please. No. Yeah. Does anyone know a word in English that means minimum or maximum? It could be either, yeah? What do you think? Turning point, that's it, very good. So we can call the maximum or the minimum, they're both called turning point for the minimum or the maximum. And there's another word as well. Does anyone know? Begins with a V. No? No. Vertex. You knew it. Yes? Okay, so turning point or vertex? That means minimum or maximum. Yeah. In fact, there are many more words. 2 is enough for the first lesson. Does anyone know any more, actually? No? We have turning point, vertex, minimum or maximum, stationary point, critical point. What else? There's even more than that. Extreme point. Yes, many. But anyways, the 2 most common ones, turning point and vertex for the moment. Okay. So what I want everybody to do now is give me the turning point here. I'll give you a minute. I want the turning point. Some people have an answer? Yes? No? Someone took your calculator? You have an answer? Let's have a look at it. So, what should I do first? What's first? Take out the 9, yeah. Does anybody remember the verb for this, taking out the 9? Take out is fine, but there's another verb. Anyone? No? Take away? No. No. Factor out. Factor out. Take out. Yeah. Alright. Take out the 9 or the minus 9? Minus 9. So, minus 9. X squared plus, does this go in? 9 ones 5, 16?
Yeah.
But this does not. No, it doesn't. But I can divide by 3 maybe. Yeah. So I could do, did you make a mistake? I could do minus with a 3 here, 61, and that's as much as I can go. Yeah. Okay, so then this will equal minus 9, x plus 8 squared, and then this will be minus 61 over 3, minus 61 over 3, minus 64, which is, let me see, 61 over 3, and then 192, 192, 253. Oh, great! 253 over 3. Okay, 253 over 3. Right, you have a calculator, so this is no problem for you. Then we multiply the 9 back. This will be a plus 3. This will be like 700 and 759. Yeah, 759. So, is it a minimum or is it a maximum? Maximum at minus 8, very good. 7, 5, 9. Okay, so this is where the maximum is. So if you were to draw the graph, let's see, minus 8 and 7, 5, 9. So it'll be something like this. 8 to the left, 7, 5, 9 up. Okay. Can I scroll down? Yeah. Let's try one a little bit more difficult. Okay. So, write this down, please. Find B and C in y equals minus x squared plus bx plus c if the curve crosses the y-axis at minus 42 and has a turning point at x equals 6. So this is getting more difficult. I'd like you to try it first before I do it. I want to see if you can do it. So for this question, I'm looking for the B and the C, and I tell you where it crosses the y-axis at minus 42. So this is y equals minus 42. And I also tell you where the turning point is. The turning point is at this place. Okay, try. See how you can do. You think you have it? Okay. You think so? Yeah? I'm worried there might be too much Chinese in the corner. What do you think? Too much Chinese? Too much Chinese?
No.
Are you sure? Alright. What are you asking me? Yeah? Which word?
Why
Oh, what's this?
I got it.
Oh, this! Ah! It's this. Yep. At. Now the question is easier? Yep. Okay, let's have a look at this now. Okay. Right. By telling you this, I'm actually telling you what the C is. Yeah. Because when you make x 0, you get y equals c. That's where it crosses the y-axis. It's exactly the same as the lesson we did on mx plus c. C is where it crosses the y-axis. Same idea. So that means we already know what the C is. It is minus 42. Now the big question is, what is the B? This is what we need. So we can use this in a moment. If I complete the square, I get x squared minus bx plus 42. And I get y equals minus x. What would go here? B over 2. Yes? And then here?
42.
Don't care. We can stop here. Yeah. Because I've actually done enough to get the B. Because we can see here that the turning point will be when x equals what?
6.
Yes, and if we were to just look at this, you would say it's when x equals b over 2, which, as you said, is also 6.
Which B is 12.
So yes, you can get then that b must be 12. So we have our b is 12, and we know our c is minus 42. So this is the answer. Okay, so this one is a little bit difficult. I've seen this question only once in the exam. So for this lesson, this one would be a difficult one. But you could get it in the exam. I have seen it once in the last 16 exams. So it's not likely, but it's possible. Okay? Alright, one more type. Can I scroll down? Yeah. No, not this one, sorry. Different example. Alright. Who has a calculator so I can see? Do you have a calculator? Just you. You have one. And you have one.
Yes.
Alright. Pick any number. Give me a number. Any number. Any number you like. What's your favourite number? 9. Great. Good number. So what I want you to do is put x equals 9 in here. In this one, make x 9 and tell me the answer. Make x 9. Alright. You have a calculator? Yes? Give me another number. 7. Great. Make x 7. And one more. Give me another number. 8. 11. Down at the back, make x equal 11 and tell me what you get. You like this one as well? Yes? So what did you get? You got 434. You got 590. Down the back?
680.
You got 680. Yes? You were doing 11, was it? Yes. So all these numbers are positive. Do you think it's possible to make this negative? Maybe we should use a negative number, yeah? Try minus 5. See if you can make it negative. What do you get for minus 5? Yep. Still positive. Yeah? So for this here, in fact, it's always positive. Always positive. This one here. No matter what the value of x, it's always positive. So for this question, we want to prove that this is always positive. You got the idea? So what we want to do is prove that this is always positive. So how do you think we can do this? Well, it's the name of the lesson, complete the square. So, yeah? No. Complete the square. Complete the square will do it. Yeah. So, the first thing you could do is you could divide everything by 3 because to get rid of this. So you would have x squared plus 10x plus 77 over 3. Now, because I have the greater than 0, I don't need to take the 3 out. I could actually divide everything by 3, including this at the end, which is still 0. Yeah? Okay, what do I get here if I'm completing the square? There we go. Plus 5. And here will be 77 over 3 minus 25. 2 over 3? Is that right? Yeah. Now, I'm nearly finished. Why has this proven it's true? It's always positive. Yeah, so this is always positive, or it could be 0 because of the square. And this one? Yeah, what about it? It's always 2 over 3, so this one is always positive. So if you have a number which is always positive, plus a number which is sometimes positive and sometimes 0, the result is always positive. And could it ever be 0? No. Always positive and never 0. And this is the end of the proof. Now in the exam, you do need to write some sentence at the end to get the full marks. So it doesn't have to be exactly this, but for full marks, something at the end needs to be written. Like this. So, you know, if this was a 4-mark question, it'd be 1, 2, 3, 4 marks, like this. Okay, write this one down. Sorry, that should say always positive and never 0. Oh, you mean can you write positive like this? That is okay, yep. Question? Huh? Always positive or 0 because of the square. Do you mean this one here? Yeah. Sorry. Yes. Okay, did you write this down? Yeah? Okay, now I'll give you some questions to try. Do we have class tomorrow?
Yeah.
No. Of course. A from all of them. 1A, yeah, 1A, 2A, 3A, 4, 5 and 6. A in everyone. Yeah, you can do it now for a few minutes and then we'll start the next lesson. A in each. 1A, 2A, the next page. After the last page. What page is it? 12. Okay. Okay. Yes. Just about. Yes, really. Just about. You don't like sentences, no? A in each. You can do them now for a few minutes, and then we'll start the next lesson because I'm sure you would rather finish at 3:40 because you don't have class. You know, your choices are no break, finish at 3:40, or break and finish at 3:50. The first choice.